Hi guys, I'm going to answer the questions from our exit tickets from sections 3.2, 3.3, and 3.5. So in section 3.2 and 3.3, the first question asks for easy ways to count atoms in space-filling models. Unfortunately, there's not really an easy way to do this. Practice, of course, is going to help you figure it out, but also using computer models where you can rotate the structure around and see all sides, because like we talked about, one of the difficulties is that things can hide. So if you can rotate it and see the back side, then that helps. Do we learn about some geometric names for structural bonds? Not in Chem 101P. When you take Chem 1A next semester, you will learn all of the names of the shapes in Chapter 10. Will we have to learn to draw a structural representation? So again, in Chem 1A, you will learn how to do this in Chapter 9 with very small molecules. And then when you take organic chemistry, you'll learn how to draw the larger ones that we've been using as examples in class. Any rules to which letter comes first? Yes. So in ionic compounds, we always draw or write the cation first and the anion second. And for organic molecules, which really just means anything carbon-based, the carbon comes first, and then the hydrogen, and then the rest of the atoms in alphabetical order. And acids, the hydrogen always comes first. They fall into the ionic category. And what am I missing? Molecular compounds, which we'll talk about today in class, the most metallic nonmetal, or the one that's closest to the stairs. Look at my periodic table over here. So on my periodic table here, there we go, our stairs are here. There we go, are right here. So it's going to be our non-metal that's closest to those stairs. And I'll explain that again today in class. And then whatever element comes after that would be listed second. This one says, I still need to understand how to divide. So I'm assuming that this is going from a molecular formula down to an empirical formula. This is the same thing that you've done in math class. You just have to look at the numbers of the subscripts and figure out the biggest thing you can divide them by. And it's okay if you have to divide them more than once, meaning if you look at them and you have a 4, an 8, and a 4, and you know you can divide those all by 2, now you have a 2, a 4, and a 2, and you know you can divide those all by 2 again, now you have 1, 2, and 1. And that's okay if it takes you more than one time. You just keep going until you can't divide them anymore. The next one says, how do you remember the positive and negatives on chart? So I don't know if this is referring to the periodic table chart or the T43 chart, but my answer is the same for either one. You just have to memorize them. So flashcards work really well, or getting blank periodic tables and just labeling them. This is a repetition thing. Like most of the things we've done in class, you're going to learn it the more you practice it. This is in section 3.5, and the question says, I still don't understand the groups. I don't actually know what this is referring to. Yeah, I'm trying to think what this could refer to. We talked about the different types of cations and the different types of anions. I'm guessing that this might have something to do with the polyatomics, because that's usually the more difficult part of that section. Come talk to me if you have questions about that one, because I'm not sure how to answer your question. This one says that they need practice reviewing the rules and guidelines, so hopefully using those little cards last week helped with that. Again, practice, practice, practice. And then the last question says, how would you determine the number of charge to get ite, ate, and ide, and when to use it? Okay, if an element ends in ide, IDE, that means it's by itself. So sulfide is a sulfur with a 2- charge. Now I know it's a 2- charge because of where it's located on the periodic table. Ites, ates, perates, and hypoites are going to be based off of that T43 that we talked about. The charge doesn't change. So for example, sulfate is SO4 with a 2-. Sulfite is SO3 with a 2-. Hyposulfite is SO2 with a 2-. And persulfate is SO5 with a 2-. So all that's changing is the number of oxygens. The charge is going to remain constant. And how to remember those? Practice, practice, practice. You got to memorize that T43 table or turn those into flashcards if that table didn't make sense to you. So if it has a T at the end, ite or ate, that means it contains oxygens and it's a polyatomic. If it has a D at the end, ide, then that means it's just the nonmetal and it has the charge based off its location on the periodic table. Okay, I hope that that helps. On Wednesday, I will post a video for your questions from 3.6 and 3.7 in preparation for our quiz on Thursday. All right, I'll see you guys in a few hours. Bye.